Hello students. So today we solve some numerical problem on current electricity, and that's very important in board and JEE and NEET exam. Okay. So if you solve these numerical and it's very easy to get 10 marks easily. Okay. There is a 2-3 numericals maximum. If you get one and two numericals sure in board exam. These are very important also. Okay. So here we solve. There is a need practice to solving these. Okay. That's why we solve some basic numericals. Okay. Some example, and this example we choose from H.C. Verma book. There is a numerical example. Numerical. There is a point A. There is a point B. There is a point C. There is a point D. There is a E, and there is a point A, and all register connected A to B, B to C, D to C or C to D, E to D, F to E, and here A to F, and E to A to D, and the register connected A to C. And here is a given, that is 6 ohm, that's the 6 ohm, that's the 6 ohm. Okay, and here is a 3 ohm, that is a 3 ohm, 3 ohm, 3, 3 and 3. Calculate RAB, total resistance across A and B terminal. Okay, that's very important. How to solve this type of numerical, and you see the diagram very carefully. Okay, so when you calculate A to B terminal, total resistance between A to B, first copy the diagram. And see that there is a junction point and there is a some normal point. So see that A point is a junction point, B is not a junction point, C is not a junction point. C is a junction point. Sorry, D is a junction point, E is a junction point, but F is not a junction point. So here F and B are not a junction point here. And calculate the total resistance between A and B terminals. So here the first step is remove that 3 ohm resistor. And remember there is a 3 ohm resistor. Okay, don't forget that the 3 ohm is important. And see that F and B are here the 2 points only. So starting from F, either B. If you starting from B, you see that there is a after B, C, A and B, C, D, there is no series of parallel combination here. So now if I try to start F, so there is see that these 3 ohm and these 3 ohm are in series connection, because there is a line, a single line here, a single path. So these 3 and these 3 are in series connection. So total resistance between 3 ohm and 3 ohm, that is total means plus in series, so get a 6 ohm. So remove these two and put a 6 ohm resistor. And these 6 and these 6 are in parallel. These and these are in parallel. So there is a why, because A and E are the two junction points, and these two resistors are directly connected between these two junction points. So that's why these two resistors are in parallel. So we know the parallel concept. There is a reciprocal concept, that is 1 by RT. So 1 by R1 plus 1 by R2, and the shortcut is RT equal to, if 2 resistor here, so R1 times R2 by R1 plus R2. So 6 times 6 is 36 divided by 12, so that is 3. So remove these 2 and remove this 6, and that is a 3 ohm resistance. And now E is not junction point now. E is not junction point here. After solving that, E is not junction point here. Now these three and these three are in series. So just must be added here. So 3 plus 3 we get 6. 6 and 6 parallel. So similar concept, A and D is a parallel. So two junction point, A and B two junction point, and these 6 and these 6 are directly connection between these two junction points. So that's why these two are parallel. So 6 and 6 parallel. So we get 3. So these 3 and these 3 are in series because D is not junction point here. So it is just connection. 3 plus 3 is 6. So remove these two. Six here. 6 and 6 are the parallel. So you get 3. Remove that and just get 3. And now these 3 and these 3 are in series. So simple remove. And you put 6 ohm. And there is a 3 ohm resistor. Firstly, we start to remove that 3 ohm resistor. Now put that 3 ohm here. Now. And now A and B, if I calculate from A and B, and you say that sir, there is a not a junction point between A and B. Yes, wrong. That's A and B are the two junction points, right? So here, if you connect the probe, a multimeter, there is a device to measuring the resistance or voltage or current. The two probe are connected these 2 points, and now there is a junction point. That is also a junction point, and these 6 and 3 are in parallel. Otherwise, these two resistors connected between these 2 points directly. So that's why these two also called a parallel. Okay. So we get total resistance RAB 6 and 3 parallel. So 6 times 3 divided by 6 plus 3 9. So 18 by 9 and you get 2 ohm. The final answer is 2 ohm. That's a basic approach to solve the total resistance problem. Okay, that's very important. How to approach that solving these type of numerical. Okay, and this numerical collected from H.C. Verma book. That's a very great books. Okay, if you want to solve, there is a huge number of numericals. If you want to solve that numerical, use that H.C. Verma books. Okay. Now we take another example. Suppose another example number 2. So there is a circuit. Okay, so given data is 1 volt, that is a 2 ohm, that is 2 volt, that is 1 volt, here is 3 volt, that is 1 ohm, here is a 2 ohm, there is 3 ohm, that is 1 ohm. Here the point is A, B, C, suppose C and D point here. So calculate potential drop between VBD first and current across all resistors. All. How to solve this? First, to see that potential drop across B to D. How to calculate that? So potential drop across B to D means, so B to D, so B is the higher potential, D is the lower potential. So here is a current passing from B to D in that direction. So we see the answer, what calculate and put that current direction. Okay, so that's why I put a current direction with the help of KCL. So we choose current direction, suppose in that direction current, in that direction, suppose in that direction. Okay, so one current in that direction. Suppose we say that is I current, and suppose that is I1. Suppose there is a called X. So apply KCL at point D. So inward be the plus and remove minus. So I plus, I1 minus, and X be the minus, that is equal to 0. So X equal to I minus I1. So here current passes to I minus I1. Now remove that X. That's the basic way to apply KCL at any point. KCL is a Kirchhoff current law and applied a junction point. Okay, there is a junction point D, or KCL junction rule. Now apply KVL. And current passing from B to D, you know that. Okay, so that is I times 2 ohm resistor. Okay, so IR from Ohm's law. So find I and we get potential drop across VB to D, VBD. So here apply KVL. There is 2 loop. Suppose we choose clockwise, the loop 1. KVL at loop 1. Okay, so how to KVL at loop 1? How to apply here? Starting from point D, so this direction and this direction will be the same. So plus 2 minus, that is 2 volt. So plus 2, the current that is I1 in that direction, I1, that is I1, that is series state path or single path, that is a series actually connection between these are the series. So current value is not changed, that is I1. So get plus 2I1. So same direction, plus 2I. Here is a 1 I1. So plus I1, that is a plus 2 minus plus 1 equal to 0. Sorry. There is a mistake. Okay. So in books there is actually, sorry, in that case. So that's why that is the minus 1. So minus to plus direction. Okay, sorry, wrong copy here. Okay. Now otherwise you put that same if you want to apply KVL, it is the same, but question the wrong copy, so that's why it changed that. Okay, so now that is I1 and I1, that is 3I1. Okay, 3I1, and that is 2I plus 2I, 2 plus 2 minus 1. Plus 2 minus 1 means get plus 1 equal to 0. So that is 3I1 plus 2I equal to minus 1. Okay, now apply KVL on loop 2, other loop here. Same clockwise. Okay, suppose loop 2. So here from starting from D point, so minus 2I. So minus 1. So these 1 and these 3 are the series, just be added. So 4, and they are in opposite direction, minus 4. I minus I1, I minus I1, and that is a plus 3 equal to 0. And now here we solve this. 2I minus 4I minus 6I. So minus 4 minus 1 plus 4I1. So minus 1 plus 3, that is get plus 2. Okay, minus 1 plus 3 get plus 2 equal to 0. So that is equation number 2, and we solve these 1 and 2 and we get I value here. So from equation 1, so 2I plus 3I1 equal to minus 1. So minus 6I plus 4I1 equal to minus 2. So as I multiplied by 3, that is multiplied by 1. Okay, so get 6I plus 9I1 minus 3 minus 6I plus 4I1 minus 2. No need to sign change here, so that's why these two are cancelled. So that is 13I1 equal to minus 5. So I1 equal to minus 5 by 13 ampere. Now put the value of I1 in equation number 1, or if you wish to put equation number 2, we get both in same result. Okay. So put the equation number 1. So here we get so 3I1 means 3 times minus 5 minus 15 over 13 plus 2I equal to minus 1. So 2I equal to minus 1 plus 15 by 13. So minus 13 plus 15 upon 13. So we get plus 2 upon 13, that is 2I, 2 to cancel. So I equal to 1 upon 13 ampere. So get the I value here and put that equation here. VB minus D. When you put I here, we get potential drop across VBD, D's terminal, BD terminal. That is 1 upon 13 times 2, 2 by 13 volt. That's the first answer we get. Second answer, current across all resistors. Here is a resistor, suppose that 1, 2, 3, 4, 5. So current across 2 ohm resistor, we know that. That's the 2 ohm resistor current is get 1 upon 13 ampere. I. Okay. Now we know that I1. So I1 that is minus 5 by 13. So current across these 1 ohm resistors is minus 5 by 13 ampere. And here the 2 ohm same minus 5 by 13 ampere. And these two resistors the same current I minus I1. So here I is 1 by 13 and I1 is minus 5 by 13. So here 1 by 13 minus of minus plus 5 by 13. So minus this minus, so that minus with the plus. So 5 by 13. So that is equal to 5 plus 1, 6 by 13 ampere. So that is a 6 by 13 here, 6 by 13 ampere here. That's the easiest way to calculate current, these two current across all resistor, or solving these two formula. This, okay, the easiest way. And if you know the how to apply KCL KVL, that's a very basic to solve that this type of circuitry problem. Next we solve that another numerical. Okay, so here we solve another numerical for better understanding KCL KVL problem. Take another numerical, suppose example number 3. Here is that a circuit given, okay, there is circuit, suppose R1 EMF 1, a point, R3 R2 EMF 2, that is a beta. Okay. So calculate or find the current through the 3 resistor. So current through 3 resistors. So IR1. So IR1, IR3, IR2. Okay, that's important. Calculate IR1, IR2 and IR3. How to calculate that? Is that suppose that the data is given, suppose not data actually given there, suppose data is given, suppose the data is called, that is a 1 ohm. Suppose basic simple, that is a 1 ohm, that is called 1 ohm, and that is supplies 1 volt and 1 volt. Okay, the data now I put here in arbitrary data here and calculate. Okay, how to calculate these type of numerical? First we apply KCL and KVL. Okay, so now we apply KCL. KCL is that suppose we current direction we choose, suppose plus to minus here, suppose in that direction current flow. Here is say in that direction current flow, and we choose that direction current flow. Suppose that is a I, and suppose it's called I1. I enter, I1 leaves, and suppose another X is enter. So KCL at point B. So KCL at point B. So these I be the enter, X be the enter. So I plus X minus I1 equal to 0. So X equal to I1 minus I. Okay, so X equal to I1 minus I. So now remove the X and put is I1 minus I. Okay, now solving this. Now I apply KVL in, there is a 2 loop. So one loop is here. Suppose there is a in that direction, if you loop in that direction. That is a loop 2. So KVL on loop 1 from starting from point A, that is 1 volt from that direction, minus to plus, so that's a minus 1. That is a IR1. Okay, so IR1 means suppose there is a 1 ohm resistance, so suppose just only plus I. There is another resistance R3 here, and now that is the same direction, so plus I1, then R3 also be the 1, that is equal to 0. So I plus I1 equal to 1. That's the equation number 1. Now apply KVL on loop 2. So starting from here, and that is the opposite direction. Okay, so that means I1 minus I minus, and that is plus 2 minus plus 1, and that's the opposite direction, minus I1 equal to 0. Now I1 minus 2 I1 minus I, that is equal to minus 1. So here I plus 2 I1 get 1. That's the equation number 2 here. Solving 1 and 2. Okay, so I plus I1 equal to 1. I plus 2I1 equal to 1. So minus and minus and minus. So you get cancel these two. Suppose that is these two are the cancel. So I minus I1, that means 1 minus 1 0. So I1 equal to 0 ampere. Okay, so I1 be the 0. So I equal to 0 something this. So I equal to 1 ampere. So now simple. Okay, I be the 1 ampere. So current across all resistors. So I be the 1 ampere. So that's the 1 ampere current flow here. So here I1. So I1 be the 0. Okay, ion with a 0 ampere, so that is there is a no current passes through that, that is a 0 ampere. That is actually 0 potential like that. So the 0 ampere, and I1 minus I, the 0 minus I minus 1 ampere, so that's the minus 1 ampere here. Okay, is this way means there is minus 1 ampere in that direction. So here is the plus 1. So that's the cancel these two. Okay, so that's why we just we leave that these 2 point. Okay, leave the current from these two, 1 minus 1 plus 1 minus 1 with a 0. Okay, there's a very basic how to first apply KCL and get all current direction. Now then finally apply KVL for solving that. You get 2 or 3 equation, there is a 2 or 3 unknown at the basic steps and follows, and you get current equation. And if you someone asks the potential drop across these two terminals, and if you that will be added here. Someone asks the potential drop across, if some added here, potential drop across this R1 resistor. So that is R1 means V equal to IR. So I be the 1 ampere, R be the 1 ohm. So that is get 1 volt. So potential drop across these 1 ohm resistor. Suppose that is a minus 1 volt IR. That is I is minus 1 and the R is 1. That is 1 volt. And that's the way you get potential drop in across resistors. Okay, that's the basic. Okay, so we solve some numerical, and the homework is if you solve numerical by your own as a homework problem, and you choose a homework problem, you choose any other book, NCERT, Newton's, it's one of the very important. Okay, you solve the very best books. Okay, you choose any books and solve the numerical. If you do the numerical by yourself, and then you get more concept clear. Okay. And when you concept clear, then very easy to solving this type of numerical. If you have any doubt to solving this type of numerical, always put in comment section. Okay, if you any doubt, I will try to give the answer. So today wrap up the class here. Thank you.